So we have a really awesome project that we're starting. So a customer called and said, I need a Hager 31J pull. A 31J is a flat profile pull, 10-inch center to center, and it'll be down onto a 4x16 push plate. No big deal. So this client calls for some Hager 31J pull handles. This is a movie studio. This is a movie studio that everyone has heard of, period. Hager 31J needs 4 of them, not in stock. It's a 1-inch wide, square profile, 10-inch center to center. I said, well, I can make it for you on the CNC machine. He says, yeah, send me a quote. So, needless to say, we got the job. I'm going to turn this 1-inch solid block of 6061, 8-inch by 12-inch into 4 individual pull handles, and that's what this video is about. And I hope you'll watch as we go through the journey. Unscripted drama is guaranteed. Success, not so much, but fingers crossed. Let's move on. Okay, let's tap some holes here. This is a 1/4-20 tap specifically for aluminum. Yeah, tapping holes is, you know what? Obviously I could have put this tap into the drill press, but I've never done that before, and I'm not comfortable. I don't see how that would work with a bottoming operation. A little bit of resistance there, so I'm going to back it off, clear out the holes. Yeah. Chip gets in there, you'll be able to tell that something's not progressing the way you like. You get any twist at all, definitely time to go in the opposite direction and work something free. Twist is the danger zone. A very small amount of twist is going to occur, but back and forth like I just was doing is how you not break a tap off. Plus, what is easy about soft material like aluminum or brass is, you know, I've drilled and tapped so many holes into the back of mortise cylinders, brass mortise cylinders. The tap is fine. I don't know how many I would, yeah, we're good. We're at the bottom. I don't know how many holes ultimately I'd be able to get through with a single tap. It's probably a fairly large number. So other projects coming up. Obviously we're going to look to do more custom holes now that we have some of the process sorted out. Will be custom escutcheon plates for locks. Think mid-20th century, atomic design, Art Deco design, 20s and 30s. Some beautiful escutcheon plates can be done. Yeah, that's good. We got a good start there. Bit of resistance, back it off. Maybe what I'll do in the future is use the specialty bolts, but I'll do 1/4-20, maybe a finer thread. That may be a good idea for this. I could have done 5/16 on this. 3/8 probably would have been stretching it, but we could do 5/16. No resistance, so I'm just, well, small amount of resistance. No twist, so I'm just kind of, I just kept going.
If you've not hit subscribe yet, we would very much appreciate if you did, and hopefully you're enjoying this video. Now, let's get back to it.
Yeah. So the length of our bolts is 2.25. There are countersunk washers here that are going to eat up about 3/16 of it, 3/16 of the length. So 1 3/4 thick doors. The bolts are 2.25. That leaves a 1/2 inch nominal. The countersunk washer is going to eat up about 3/16 worth. That means that our holes are deep enough. Our bolt will have full engagement. Maybe what the client wants to do is use some thread lock. All right, 2 done. 2 more to go. Now I'm alternating hands. It seats fairly well. As soon as you get to like the second rotation, you're definitely straight. Because you need those bolts to go in straight, obviously. Actually, when I got to I have a very large drill and tap set, and I realized that my 0 1/4 tap was missing out of there, and I know where it is. I have it with a different setup of tools for a different operation. A little bit of resistance here. All right. Just some buildup of material in there. It's got to get cleared out. No flex. Obviously, you don't want to be sitting tapping holes all day, so the temptation is to go fast. Unfortunately, it's one of those things that there's no way to make it faster. You know, obviously another idea to explore at some point is the thread creating component of a CNC. I've seen it done. It seems really interesting. It seems easy. I have to work out, obviously, the fixturing that would occur. Boy, those chips are just really coming out. I'm wiping that piece off because I then place it down and I don't want to get anything into the face of this pull handle. Okay. Okay. There is a car museum, I would say 500, maybe 1,000 yards, no, not even, yeah, maybe 1,000 yards to the west of my location, of where I am right now. It's called Revs, R-E-V-S, and the owner of Revs, his last name is Collier. The name of our county is Collier. He's the grandson of the Collier that the county's named after. And it's my understanding that the Collier family is the largest landholder in Collier County. And anyway, the car museum is interesting because it has over 100 cars that are, many of them are very interesting. And what the folks will tell you when you go into the museum is that the collection represents the history of the automobile. So it has the obvious cars in it. It's going to have your Ferrari, it's going to have your Porsche, but it'll also have a Buick. It also will have a Cadillac. It also has a self-driving car. They have the very first, Porsche made a race car. They actually made 4 of them. This museum has serial number 1 of those 4 race cars. Porsche called Mr. Collier and said, hey, we'd like our car back. And he said, nah, not today. He's a Porsche enthusiast, So his collection is heavy Porsche. He has a McLaren, and not the ones you see on the roads today, the one you would have seen in the 90s, which I guess some people like those cars. Nice. 3 down. He has a couple of GT, he has 2 GT40s, a Mark 1 and a Mark 2. And he had, when I was there actually about a month ago, he had, there was a third, I think it was a Mark 3, I don't recall. It was on loan from someone. He has an incredible collection of hood ornaments. Well, cars in the 20s and 30s, a hood ornament was quite the thing. And the French glassmaker Lalique, some of you may have a Lalique in your home, I know we do. Lalique manufactured some pretty exquisite glass hood ornaments. And that's interesting. If you do end up here in Naples, it's definitely one of those things that doesn't make the list, excuse me, of things to see for a lot of people. And I think that Revs Institute is what it's called. It's just like the hardware industry. We're awful at marketing. I lived here for 3 years before I learned that there was a near priceless car collection 1 mile to the west of where I sit at a desk for 9 hours a day. I've been there 3 times. One was a docent-led tour. I absolutely suggest that you do it with a docent, on a docent-led tour. The people that work there have forgotten more about automobiles than most people will ever learn. And they are volunteers. They are extremely passionate about automobiles, and it shows. And they know stuff, and they are really happy to share their knowledge. They're also really quick to tell you don't touch anything, as would be common sense. Gift shop, back of house tours. Every vehicle in the place gets what they, the word they use is exercised at least once a year. The race cars are actually put onto a track with professional race car drivers. So this material is actually put through its paces. Okay, we have one more hole to go. Then what will happen is this video will end, and the final videos are going to be just me drilling the 5/16 holes in the aluminum push plates that these pull handles are going to sit over and on top of. Really good there. And this combination of drill bit and tap, that'll be kept on record. So making these in the future will absolutely be done with the use of this combination of drill bit and tap. I'm really happy with the performance, the quality of the finish. And as I've said earlier, we're gonna, oh, getting some resistance there. It's always the last one that I have to be mindful of. Overconfidence is not, okay, that definitely cleared itself out. Overconfidence is what causes trouble. I have a customer here who I supplied a windstorm rated door to and a multi-point lock. His overconfidence is proving to cost him more money in the long run than just reading the instructions from the very beginning. Just because you can reinvent the wheel doesn't mean that you should. They're almost done here. Oh yeah, plenty of resistance there. Let's back this out. can see that blue finish on the end of the pole there. That's just going to stay there. I'm sure I've mentioned it, but these handles are just... Hey, Ellis. Hey. These pull handles are just meant to be props. So there we go. We're done. Let's pick it up with the push plates.
If you've not hit subscribe yet, we would very much appreciate if you did, and hopefully you're enjoying this video. Now, let's get back to it.
Okay, just to give us one final run through of these pull handles. Again, the last thing now to do is to just take the push plates. I'll clamp them down on the CNC and I'll just I'll let the CNC do the work. Pull handles, 10-inch center to center, 1-inch wide, 3/4 thick holes. And we can do different mounts on these as well. So let's move on to the push plates. Okay, so today we plan on finishing the project. I have 4x16 Ives 8200 push plates here in an aluminum finish. Unfortunately, the manufacturer sent me 32D finish. And while the finish probably isn't going to be an issue, I did not want to learn about feeds and speeds cutting 50 thousandths aluminum on my CNC at this time. So here's what we have. We've got 4 of these plates, 4x16. I'm going to drill a 5/16 hole. 10-inch center to center, 16, so 3-inch down, 3-inch up is what we're going to do. So I'll do some drawing, and then we'll make it happen. Let's do that. Okay, so let's get the push plates drawn. These are 4x16 push plates, so I'm going to... What size? Material? 19, okay, lower left. Okay, really good. So I'm going to draw a rectangle. I'm going to start in the lower left. I'm going to make my width 4. I'm going to make my height 16. And I'm going to create. There it is. I am going to draw 2 circles. Center point at X2 and Y3 with a diameter of 5/16. Create. And then I'm going to put another one at 13. Create. Bingo. Close. All right, let's select all this and let's move to a layer, new layer. Let's call it plates. Okay, go up here. Here we go. Okay, so I drew the background, the plate itself, just for reference. That's not going to end up being a vector. What I want to do is actually put a tape measure on my plates and make sure that they're 4x16. So we're really good there. The reason that the holes are 5/16 is because my bolts are 1/4 inch. So let's get both of our bolts, and let's do a pocket tool path, and this plate is 50 thousandths, so I'm going to go 0.06. We're going to go into our material below. That's fine. Let's select a bit, and I don't know what. I'm probably just going to use the 1/4 inch bit that I have. The bit that we have been using, I should say. Let's see if it's a 3 or a 2 flute. It's tool number 2, and that's a 2 flute. Yeah, this is the 1E. It's been 2 weeks since I've touched this, so it's one of those situations where I just don't recall. I need to make these videos without stops. So, yeah, that's our bit, a 752. It's an uncoated aluminum 2 flute cutter. Or chip load is what I like. None of this has changed. It is tool number 2. Select. We're going to get rid of the surfacing end mill. We will plate. Yeah, we'll just leave that. It shouldn't be a problem. Let's calculate that. Okay, so let's reset the preview. Let's check our material thickness. Yeah, it's changed. Obviously 0.05. Actually, let me put the caliper on that. Going 0.06 is going to certainly get through it. Yeah, this material is nominally 50 thousandths, and if it seems like I'm rushing through this, and it's because I marginally am. Okay, so okay. You know what? Let's let's cancel that. I won't change the material setup because the reason that I would change the material setup is because it would show me going all the way through. I won't know that I actually am, but that's okay. Let's preview this toolpath. I have to admit I do not know where it's getting that thickness from because we didn't change it here. Oh, we did change it here. Okay. I just didn't recalculate the tools. That's why. Got it. Right on. That's okay. You can change the material thickness and not recalculate. Okay. So, yeah, we're going all the way through. That's because we're going 0.6 with our finisher and suitable vectors. We're calculated, but I will do it again. Calculate. Yes. Close. Save that as a tool path. Our number 2-bit. Yeah, okay. Save the tool path. Plate. Okay, let's save it. Okay, now. So what I'm going to do is actually just now get the machine set up. Obviously turned on, zeroed, spindle warm up, and we'll just finish this job. Let's do it.
If you are enjoying this video, please click thumbs up or like, and also please consider subscribing to our channel. Let's move on to the rest of the video.
Okay, we've got the plate fixture down. I've done an air cut. I'm doing a C5 to warm up the spindle. I've only got 4 of these plates to cut, but I don't want to be cutting through material without first obviously warming up the spindle. So that's what we're going to do. We're going to pick it up with our first cut coming up next. Okay, we're going to run it. The warm-up is done. Let's just run the plate. And let's just see what we break. Yeah, I'm going to move the cold air out of the way because I know we're going to bottom out and hit something. Cold air. Okay, let's get the board. Yeah, our clamp move. Yeah, our fixturing move. Something like that. Okay, so let's go back to the lab on the fixturing. And I'm happy with the finish, the cut. The cut's fine, even though it moved, as you saw. We're going to have to get some extra clamps on there to slow that all down. So we're just going to keep moving through this. And as with all things CNC, it's always about the fixturing. So let's run this again. Okay. Alright, so, yeah, alright. Let's take that off the table and let's take a look at it. Let's just try to remember what we've done. Okay, we've recut that. It moved, the holes got a little bit odd on us when the piece moved, so let's grab a handle. What it's going to look like. The important part is the holes in the back are going to line up just fine. So what we'll do is we'll clean off the burrs ever so slightly on these plates, and let's just run the rest of them right now. But what I'm going to do is change the diameter to 3/8 on all the holes. This 5/16 is only giving me a 32nd around everywhere, so I'm going to do that, and we're going to keep on keeping on here is what I'm going to do. So I've got the tool path pre-calculated for 3/8 diameter holes. I'm just going to get the next 3 plates and we'll run through it. More fixturing happening on here than I would really like, to be frank. But it's life in the big city. Okay. Right there. More than I did expect. I wonder if I didn't have both of the vectors selected in my tool path. Maybe you can see what's going on there. Let's check our tool path. I've got 2 holes. Quantity of passes changed, and that's
That's a really wise idea, except we gotta fix some stuff here. Like the gloves on. Sometimes the hands move before the brain thinks. Yeah, that's horrible. That's what I was expecting. That's way too big. Way too big. Oh goodness. That will cover, but it's way too big. That means the tool pathing was set to 3/8 radius, and not 3/8 diameter. 0,0,2. Move our tool back. Let's correct our tool pathing. No, radius is good. Because I changed it to on the line rather than inside the line. That is definitely the mistake that was made. You want to be inside the line. Close. Save. Save tool path. We've got it dialed in. Let's swap out our plates and let's just keep going. That one hole that's
5/8 diameter is not a problem, because the pull handle is large enough to cover it, and that's just how that's going to be. Recut this one again. I didn't care for very much. So now we've got some production going without really too much trouble. Now we've figured out how this all is working, even though a couple of plates got boogered up. What I just did there was turn off the vortex tube. Certainly what you're going to notice is that the compressors will turn off. Right there. When the vortex tube is on, those compressors don't turn off, but they blow a lot of cool air. All right, so yeah, we're in really good shape. Holes line up where they ought to. And that's what this finished pole is going to look like. Actually, let's take this just one step further. I believe we can. I have some machine screws and some fender washers. And we'll attach the poles to the plates. And then we'll know exactly how these look. We'll know exactly what these look like. There you go. That's what the finished plate looks like. It's nice. Gonna want to break these corners next time I do these, obviously. Put the rest of these on here. There we go. Second pole handle. Here's our third pole. This third one's got the best finish on the outside. And I think it's because I was using a coated bit on that one. Last pole handle to put the plates to. The client is in quite a hurry to get these pole handles. So we're just going to let it roll. There's our last pole. Let's lay all four of these down on the work top here. And here is our completed project. They're not awful, but we'll summarize right now, and we'll talk about how they'll be better next time. I still have the original material on here. Gonna need a little break on these edges. Gonna need a router table for that. That'll be experimentation next. Our next level of experimentation. Alright, let's wrap up this project. So, at the end of the day, the pull handles aren't awful, and that's the finished job right there. 1 inch by, I think, 3/4, right? 10-inch center to center. Backed down to a piece of 50 thousandths aluminum, just a typical push plate. There will be through bolts, or a type 1 mount is what these will be. Fasteners for the push plate are included. And so how to make it better next time? For sure, getting the fixturing on the table really well. This is where my piece, after I went through the masking tape and the CA glue, I had to put that piece back down after I had already created the tool path. And I was within 30 thousandths of an inch of my bit touching the bottom of this. Bottom line is that's the bottom of the pull handle. It won't ever be seen. Because time is of the essence, that's going to be fine. So how will it be better next time? I have ordered a crosshair laser for my Z-axis. So I'll be able to get the position of that bit better moving forward. That'll be number 1. Number 2, I've learned that the blue tape and CA glue really works. So I shouldn't have to put down a new piece of work material without making sure it's right on the money. I learned that the path steps are really important. I got to a point where I was doing, on those last pulls, I was doing 60 passes on this 1 inch thick. That meant a 60th of an inch every time, and that gave the bit no trouble at all. It took longer than I would want, but gave the bit no trouble at all. The next step, as I've been told and taught, now it's time to optimize. You got to optimize the tool pathing, or the feeds and speeds, actually. So I learned that about it. Having the correct 00 datum for your plate, that's really important. I was admittedly eyeballing it a little bit just to get finished, which is very atypical, but this stuff has to ship tomorrow, period, end of sentence. Whether or not that's off 1/8 of an inch, this is going to be used in a prop in a movie, or a TV show, not a movie, and is a prop only and might not actually ever be used. So at the end of the day, I am not concerned about some of those things, but it won't happen next time because we've learned better. So feeds and speeds really is crucial. Fixturing it down, boy, we learned the hard way. Took that leap of faith on blue tape and CA glue, and boy, oh boy, it worked. No complaints, no problems whatsoever. So I'm happy with that. So I'm going to wrap this up. Thank you very much if you have stayed with me on this journey. I do appreciate it. And we'll move on to the next project. Thanks again.
Thank you for watching, and if you've enjoyed this video, please click thumbs up, please subscribe, and maybe even send the video to someone that you know. Thank you.